Alright, so what we've learned today is there's a logarithmic scale, and it looks like a regular number line, but really it has to do with, this is 10 to the negative 3, 10 to the negative 2, 10 to the negative 1, 10 to 0. But if you take the log of these numbers, the log of 10 to the negative 3 turns out to be negative 3. So if you take the log of these exponential numbers, it just makes negative 3, negative 2, negative 1. Log of 10 to the 1, 10 to the 2, 10 to the 3, it creates this log scale. Why do we need a log scale? Because some things are so big or so small that the only way we can describe them is with exponents, and then with logarithms we can figure out what they are, because logarithms are exponents, okay? So that gets us to pH. So if you talk about pH, you're talking about a concentration of hydrogen atoms. Now, you're talking about a whole vat full of water, 1 liter of purified water, and how much hydrogen is actually in there. It's not a whole lot as far as a concentration, okay? It might be millions upon millions of hydrogen atoms, but as far as a concentration, it's a very small concentration. That's why we'll use logarithms to describe pH, all right? Earthquakes can be really, really big, but the difference between one earthquake on a scale of 6 to 7, it's 10 times as big. So earthquakes get pretty intense the larger they get. That's why we want to use logarithms to describe them, okay? S is your standard earthquake, okay? And we always let S be 10 to the negative 4. And then M is the magnitude, how big it is. They will also describe magnitude in terms of TNT. They'll say, like, for instance, a 6 magnitude is like 10 times to the 6th power of that many tons of TNT. So if you can put that much dynamite in a mountain and blow it up in terms of tons, that's like, well, that's a million tons of dynamite. Okay, that's a pretty big earthquake. Yeah. Now, same thing with the decibel scale. It's in a logarithm scale too, because it is, the louder you get, the more intense it gets, and that's the intensity. I0 is always going to be 10 to the negative 12, and that is just a standard. That's the smallest, the lowest that you could hear as far as your ears being able to hit. So let's shift to our notes, all right? So first example, right? Let's take a look at it. Example 1, the hydrogen ion concentration of a sample of blood was measured to be about 3.16 times 10 to the negative 8. Now this is a pretty easy problem. So let's go back to what our notes say, okay? So pH, we've got pH is equal to the negative log of my hydrogen atoms, all right? So in this case, we're just going to rewrite this as the negative log, and this is my concentration right here. That's what it tells me, so I'm going to put that into my formula. So negative log of a 3.16 times 10 to the negative 8 power. Okay, so then I'm just going to use my calculator. Put it in my calculator and see what I get. I'm going to go negative log of 3.16 times 10 to the negative 8 power. And I get about 7.5. That's a pH. Now, 7, if you know anything about chemistry, 7 is neutral, right? Anything higher than 7 is going to be an acid or acidic. Anything below 7 is a base. So this blood is slightly basic.
Yeah, it's the other way around.
No, that's right. No, because a pH of 2 is a really strong acid, and a pH of 12 is a pretty strong base.
Yeah,
You said it the other way around.
yeah,
I did?
You said if it's higher than acid.
If it's, okay, so if the number, okay, I got it right. If it's a, there you go. Yeah, so from 7 to, say, 1 is acid. That's what I wanted to say. And from 7 to about 14 is a base, right? There we go. Okay. Next one. The most acidic rainfall ever recorded in Scotland was in 1974. Probably acid rain, right, of 2.4. Find the hydrogen concentration. So let's go back to our formula, okay? Our formula is this negative log of our hydrogen concentration, okay? And we're going to set that equal to a 2.4 and find out what was the the hydrogen concentration, okay? So I'm just going to solve. Well, the first thing I'll do is I'll bring over the negative. So I'll have the log of my hydrogen concentration is equal to a negative 2.4. I'm going to shift it from log form to exponential form, but the base right here, there is a invisible base here, base of 10. Everybody agree? Visible base right here of 10. So we're going to rewrite this as 10 to the negative 2.4. And I'm just going to use my calculator. That's pretty easy. 10 to the negative 2.4. And I get an answer about 0.004. Okay. And I can rewrite that as 1, 2, 3, right? So I can write it as 4 times 10 to the negative third, okay? And that'd be your hydrogen concentration. Okay. Not too bad. All right, let's do an earthquake problem, okay? Example 2. So the magnitude of an earthquake, okay? The magnitude is how much, think about this, how much dynamite. Think about an earthquake as magnitude is how many tons of dynamite are in that mountain, okay? But it has an intensity of 3.75, okay? So if you were to take a look at the seismograph reading, you know, the little thing goes like this, goes, you guys have seen that, right? Goes back and forth. So that means that this is a 3.75 centimeters is the broadest stroke, okay? So that's intensity. They read that and they go, well, how big was this earthquake? How many tons of TNT was actually in the earthquake? So we'll just use our formula. We've got a magnitude formula, M is equal to our log intensity over S. Okay, that's our formula. Now S is always going to be 10 to the negative 4, okay? And that's your standard size earthquake. That's how they compare one earthquake to the other, is they use this number, okay? I think I read also somewhere like that would be the intensity of an earthquake if you were like 100 kilometers away from an earthquake, okay? A standard earthquake. The epicenter. Huh? That's what the scientists come up with, standard earthquake. It's a great question. You know what, Ryan? It's a really good question. So let's figure out what this is. So if you just plug this into M is log of my 3.75 divided by my 10 to the negative 4. We just use our calculator, right? Just use your calculator. I'm going to go log 3.75 divided by 10 to the negative 4 power, right? And let's see what we get. About a 4.57 magnitude, or I guess it'd be 10 to the 4.57 tons of dynamite. It's a lot of dynamite. Okay. All right, the next example just kind of works backwards. If you've got a 5.1 earthquake, how much is your seismograph going to go back and forth? Does that make sense? An earthquake goes, it shakes the earth. What's this? How big is this machine going to go back and forth? All right. Seismograph, yeah. So we set it equal to the 5.1, right? Because we've got M equals our log of I over S. And in this case, that's my magnitude. So I set it equal to my 5.1 equals my log. And I'm looking for my intensity. I don't know what that is, but divided by my 10 to the negative 4 power, okay? Now, what I'm going to do is probably just well, it's inside. So what I'm going to do is probably first just break it up into 2 log. 5.1 equals log of I minus log of a 10 to the negative 4, okay? And I can't multiply because it's inside. Does that make sense? Yeah. But I can break it up by subtracting, right? And this I can just use my calculator, right? And that should probably be negative 4. That's my guess. Okay? So that's probably going to be negative 4. I'm running out of room here, but I'll slide it down. So I'll go 5.1 equals log I of negative 4. In fact, you can try it in your calculator, but we know it floats down the exponent, right? You know it floats it down. Log of anything with an exponent, it just floats it down. Or just try it on a calculator. You will get negative 4. So then I'll have 5.1 equals 10, log I plus 4, right? I'll minus my 4. I get a 1.1 log of I. Now I want to solve for the intensity, so I'm going to change it to exponential form. And of course there's a base 10 here. So I'll change it to exponential form. I'll go 10 to the 1.1 is equal to my intensity. And 10 to the 1.1, let's find out what it is. 10 to the 1.1 power. And I get about 12.5, about 10.6, 12.6, sorry. 12.6, and that's in terms of centimeters. So that thing's really cranking pretty good as far as centimeters go, back and forth. That's what this intensity means. If you look on the seismograph reading, it's flashing back and forth. Okay, not too bad, not too hard. Okay, let's turn the page. Okay. All right.
Richter scale go?
What's that?
How high does the Richter scale go?
Yeah, it's by tens, by powers of tens.
Oh, 4 times as intense. So,
Right.
So, yeah, that
So
would be
if this one's 4 times as intense, then what we've got is the magnitude is going to be my log. Okay, we know that this one's already is 8.3, okay?
So you just have to multiply it by 4?
By 4, well, we multiply the 4 on the inside, okay? So we're going to go log, this one's going to be 4 times as intense, right? Over S. But we know S, I'm not going to write S. I know S is the standard, which is 10 to the negative 4, right? And I knew this one was already 8.9, right? Doesn't it tell us? No, 8.3. Sorry, 8.3. I already know this one's 8.3, okay? So then I'll go the magnitude is equal to the log of this 4 plus the log of my intensity, right? Minus my log of 10 to the negative 4, okay? So all I'm doing is the rules that we did last week, okay? So log of 4 plus the log of the intensity. And I actually know this. This is 8.3. It told us that the 1906 San Francisco was 8.3. So I can put 8.3 here. And I know this is just 4, right? So I'm going to go, okay, magnitude is log 4 plus, this is 8.3 plus 4. Okay, I got the 4 because this comes down. Okay, I can add those two and get a 12.3, right? So I get m is equal to log 4 plus, that's a 12.3. And what is log of 4? I don't know. I'm going to use my calculator, right? So log 4 turns about a 0.6. So I'm going to have a 0.6 plus a 12.3 plus my 12.3, and I get an answer of about 12.9. That's the intensity, okay? All right, let's talk about decibels, okay? So,
Yeah, is that the intensity or
right.
Magnitude.
That's magnitude, sorry, my bad. Yeah. Okay, example 4. So, find the decibel level of a jet taking off. Now, I actually lived on an Air Force base, and man, they can be really, really loud if you're standing close. Super loud. So if it's 100, first of all, let's go back to our decibel. And they use big B, but it's dB for decibel is equal to 10 log of I over I0. But I0 is always going to be 10 to the negative 12. It's just a standard. It's the lowest thing we could hear at a very small whisper, okay? So in this case, the intensity is 100. Let's put 100 in here. And the decibel level of the jet is 10 log of 100 over 10 to the negative 12. I can just use my calculator to give me the answer, right? 10 log 100 divided by 10 to the negative 12th power. I get about 140 decibels. Rock concerts, I get about 200, and your ears are splitting, huh? Seahawks game, super loud if you're there, okay? Okay, now, last one. Find the intensity level of a motorcycle if it was at 90 decibels. So we'll set it up. We'll set our 90 here. Here's our formula. We'll put our 90 right there, okay? So we'll go 90 equals our...
What would the legal limit, Mr. Davey?
That'd be a good question. We'll have to Google that when I'm done.
70 decibels?
I don't know. I know that there is a legal limit of what you can have.
It's 70.
Is it 70?
Yeah.
Really? You knew that.
My
That's-
brother's car broke that.
Yeah. Basically any car, like, it's not loud at all. Cops just don't compute.
Okay, so we got to solve for this. This isn't too hard to solve. First thing, let's divide by 10. Divide by 10, divide by 10. I get 9 equals log, and I'm going to do this, log of I minus log of 10 to the negative 12, okay? And because it's a log, I can float the exponent down, right? I'll rewrite as 9 equals log of the intensity plus 12. Hopefully that doesn't bother you, but I floated down the negative 12. I skipped a step. But because when you take log of base 10 of 10, you float the exponent down, right? And the negative with the negative 12 makes a positive 12. Okay. And I'm going to subtract 12 and get negative 3 equals log of I. There's a base here, base 10, right? We write as 10 to the negative 3, and that's my intensity, okay? All right, that's all I have. And you guys, we're going to work hard on this.